All right, welcome back, everyone. Mr. A here again, welcoming you to a new chapter in Algebra 2. We're in Chapter 4 today, first section of Chapter 4, and we're going to talk about graphing quadratic functions. But before we do that, today, Avila Beach. Got my Avila Beach shirt on today. Visited out there in California this past summer. So. All right, well, let's get started. Let's take a look at our objectives, first of all. And our objectives for this lesson are to graph quadratic functions. And secondly, to find and interpret the maximum and minimum values of a quadratic function. Okay, so here's first step is we want to talk about the general form of a quadratic function, and that's going to look something like this. F of x equals ax squared plus bx plus c. Remember before we've talked about this, f of x is really just a big y. And then in this situation, a, b, and c are numbers. Okay, kind of like remember before we talked about standard form, ax plus by equals c. That was for a linear equation. Well, this is for quadratic. Ax squared plus bx plus c. A, b, and c are just numbers, just like they were before. And the first part, the ax squared, or some number times x squared, they just call that the quadratic term because that's what makes it a quadratic function, is the x squared. The linear term, that's the second part there, the bx, or the some number times x, and the constant term is c. That's the number that's all by itself. So in this example here then, what term is going to be the quadratic term? Well, that's the 5x squared. And what's the linear term? Negative 7x. Good. And then, of course, the last thing is the constant is 1. Okay? So just so we know what to call those when we're working with those. All right, so let's kind of start looking at some of the stuff here that we need to know. All right, so first of all, you can see here, we've got the ax squared plus bx plus c. The first important thing to know is the y-intercept right here. The y-intercept is, there's a lot of stuff in here, but basically it's just the y-intercept is c. So in this formula, ax squared plus bx plus c, the number that's all by itself, that's the y-intercept. Just like slope-intercept form, y equals mx plus b. In that case, b was the number by itself, and that was the y-intercept. Now it's c, but it's still the number that's by itself out here. So that one should be pretty easy to remember. But that's the first thing that we got to know, is that the y-intercept is just this number out here that's by itself in this formula. All right, here's the other really, really important thing, okay? This is something that you should have memorized by the time we get through with all this. All right, a couple of things that this does. First of all, axis of symmetry. Okay, so here's the axis of symmetry. In the down here in the kind of the graph of this, you see the parabola. Anytime we have a quadratic function, remember it makes a parabola. The line that splits it right in half, that's what's called the axis of symmetry. All right, so the axis of symmetry, all it is this line that goes straight up and down that just cuts it in half. And so you can see here they talked about the reflection of the y-intercept. Basically everything on this side of the line gets reflected across the other side. So it's just like two mirror images. And so the key here is this. The axis of symmetry will always be x equals the opposite of b over 2a, or negative b over 2a. I usually see opposite of b. So remember, I'm just going to write it again here. X equals the opposite of b over 2a. If you can remember that, that kind of sets everything else up. And so what that means is, remember the a and the b here? Remember the a, the b, and the c in our formula? All you're going to do is use the number that's in front of the x, that's the b that goes in up here. The number that's in front of the x squared goes down here. And when you work that out, you're going to get x equals some number. And that's the equation of the axis of symmetry. And remember, we've talked about this many times before, that a line that goes straight up and down, its equation will always be x equals some number. Okay, so it's always x equals some number. That's true here too, because it's a line that goes straight up and down. And then the other part of this, which we get from the same little formula here, the opposite of b over 2a, is the x-coordinate. Because if you look down here, the x-coordinate of the vertex is just the bottom point on the parabola. It's as far down as it goes before it starts coming back up again, which is on the axis of symmetry, and it's just that bottom point there. Now if the parabola goes the other way, if it gets flipped upside down, then the vertex is just that top point, but it will still be on the axis of symmetry. Okay, so whatever this works out to be, let's say in this case, based on what this graph looks like, that might be x might be 3 there. Let's just guess at it and say there that x is 3. That's the equation, let's say, for the axis of symmetry, and the x-coordinate at the vertex would also be 3 in that case. Okay, we don't know what y is yet. We'll figure that out a little bit later. All right, so those are some of the key things there. Y-intercept is just a number by itself. And then remember, opposite of b over 2a. If you haven't written that down yet, write it down. Okay? Right now, write it down. Okay? Opposite of b over 2a. Okay, Aubrey, you got that written down? Good. All right, next. First example. All right, here's an example of a quadratic function. F of x equals x squared minus 4x plus 2. So what do we want to do with this? Okay, first of all, we want to find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Okay, we want to find that out. Then we're going to make a table of values, and then third, we're going to graph it. Okay, so that's basically what we're trying to do here. All right, there's our flipping graph. All right, first of all, y-intercept. What's the y-intercept? Okay, let's find that first. Y-intercept is 2. Okay, that one's kind of easy. Let's go ahead and graph that point so we remember it, and we don't have to look back at it later. Okay, we've put a dot there on the y-intercept. Remember, that's where we begin it. All right, so now let's find out some of this other stuff, the axis of symmetry. So remember what we have to do for the axis of symmetry. X is going to equal the opposite of b over 2a. All right, so what's b? All right, if you look at this here, b is the number in front of x, and whatever sign this is, that is going to be part of b. So because remember the formula said ax squared plus bx, so this would be like a plus a negative 4. So negative 4 would be your b. So the tricky thing here is that it's the opposite of negative 4. That's the opposite of b over 2 times a, which is 1. Okay? So we plug that in. What's the opposite of negative 4, or a negative 4? It's a positive, right? So this really is just then what? 4 over 2, which means that x equals 2. Okay, so the equation for the axis of symmetry is x equals 2. And when you go to graph this on here, you know, I think I'll want you to go ahead and, when you graph these, to draw the axis of symmetry in here. Well, where x is negative 2, or x is positive 2, is right here. And so draw a straight up and down line here. You can make it, I'm going to do it best I can here. And so this is your axis of symmetry. Okay, so there's my axis of symmetry. Here's my y-intercept. We're starting to piece this together now. And then, of course, the x-coordinate of the vertex is going to be the same thing, right? So the x-coordinate for the vertex, I'll put a v there for vertex, is also 2. Okay, so we know that. All right, now let's finish graphing this. This is where, if you want to, you can go ahead and use your calculator. Might make finding some of the other values a little bit easier. And so So that's what I'm going to do right now. And remember, you can just go to that y equals function on your calculator, and you're going to type in your equation here. So I've got x squared minus 4x plus 2, second function, and then go to that table, and you'll get a table of values. Now the good thing here is, it'll give you the points, but you know that if your vertex is at 2 right here, or your axis of symmetry is x equals 2, you know where to look for the points. You know to look, here at 0, 1, 2, 3, 4. Look at those points right there are going to be the ones that are going to be important. So on my table here, I'm going to maybe make it over here, x and y. And we know that one of our, well, actually we know this one, don't we? The y-intercept. We know it's 0, 2. And then we'll have, let's see, something at 1 and something at 2 and 3 and 4. And okay, and that's because these are it's going to be here and it's going to go down, something like that. We'll figure out exactly where those are in a second. All right, so when I look at my my table here, I've got 0, 2 from my calculator. I've got 1, negative 1. I've got 2, negative 2. 3, negative 1, and 4, 2. And you should see that these reflect across this axis of symmetry over here. Okay, so you got 0, 2. Then we've got 1, negative 1. We got a point. And then we have 2, negative 2. There's the vertex. And then 1, 2, 3, negative 1. And 1, 2, 3, 4, 1, 2. And you notice that point is reflected across the axis of symmetry with that point. Those two are reflected across the middle. And of course that one's right on there. And then the last thing that we're going to try to do here, and this is going to be a little hard for me on this program, but I'm going to try to draw a parabola here best I can. Okay, pretty close. It's a little harder to draw on this than on regular paper. And so in that case then, right here, that's our vertex, which was 2, negative 2. And then right here is the y-intercept, which was 0, 2, or you could just call a y-intercept of 2. And then the axis of symmetry here was x equals 2. So those are some of the important things on that graph. Now you could, in this situation, it would be pretty easy to just do everything on your calculator there because all these points are pretty decent, but sometimes this axis of symmetry in your vertex is not going to be on a good point that will show up in your calculator. So you have to be able to do this opposite of b over 2a because sometimes that's going to be in between a couple of integers. Okay, so it's good to know this for those times. All right. Next thing we're going to talk about is maximum and minimum value of these parabola functions, okay? So, again, you notice we've got here f of x equals ax squared plus bx plus c. There's our equation. But now remember, back when we talked about parent functions of parabolas, remember that? We had y equals x squared, and that parabola went through 0 and it opened up. So it kind of looked like this, except you'd have to move this one up a little bit. Well, when y equals x squared, the number in front of x squared is 1. It's positive. So basically what happens is, what they're trying to say with all this stuff here is, if the number that's in front of the x squared, a here, if it's positive, the graph is going to look like this, and it will have a minimum value. It'll go down to a certain point, and then it'll start coming up. So the vertex would be down here. In the other case here, they say, well, if a, or the number in front of x is, in front of x squared, sorry, is negative, remember, that's when it flipped it upside down. Remember that? And so when it flips it upside down, the graph is going to look like this, and that means that you get a maximum because it goes up to a certain point and then comes back down. So So that's kind of how you can tell if something's a minimum or a maximum. Just look to see if this number is positive or it's negative. And then the other thing is to find the actual value. Remember in the previous thing that we just did, we found the value of the x-coordinate of the vertex. We found this number right here. Well, what we're going to do is we're going to take that and we can just plug it back into the equation to find the y that goes with it. And that, the y-coordinate, this is very important, the y-coordinate is the maximum value, or the y-coordinate is the minimum value. So when it asks for minimum value and maximum value, that's basically the y at the vertex, okay? And I'll walk you through that whole process in a second here. Okay, so those are the important things there. The number that's in front of x squared tells you if it's negative. If it's negative or positive, it tells you that if it's positive, it'll have a minimum. If it's negative, it has a maximum. And then to find the actual value, you find the y coordinate at the vertex. Okay. All right. Example 2. Here's our function here. F of x equals negative x squared plus 2x plus 3. What we're going to do on this one is we're going to determine whether the function has a maximum or minimum value. Then we're going to state the maximum or minimum value. And then we're going to state the domain and the range. Oh no, domain and range again. Okay. Not too bad on this one. And you don't necessarily have to graph it, but I'm throwing in a graph here, coordinate plane, just so you can kind of see it a little bit better. And I've got an idea that might help with the domain and the range a little bit. All right, so first of all, let's see if it's got a maximum or a minimum value. So to find out maximum or minimum value, look at the number that's in front of the x squared. There's a negative in front. So that means if it's negative, it's going to go what? The opening is going to go down, which means it's going to have a maximum value. Okay? So in this case, this has a maximum value. Now we have to find the maximum value. Okay, how do we do that? Remember what we just did in the previous section where we did the opposite of b over 2a? We're going to do that again, okay? So what's the opposite of b over 2a? Well, what's b? b is 2. So this is going to be negative 2 over 2 times, and a is a negative 1 here. Okay, so that's a negative 1. So this is going to be a negative 2 over negative 2, which just equals 1. All right, so what does that mean? That means that at the vertex, x is 1. So what we want to do is, this is not the minimum or maximum value. This is the x. And I'm going to write this here. This is the x at the vertex. Okay? We want to find the y at the vertex. So all we have to do is take this 1 and plug it back into this equation, because that will tell us what y is, because f of x is really just a big y. Okay? All right, so let's do that. So here's what I've got. I've got f of x, or y, equals negative x squared, and x is 1 here, so negative 1 squared plus 2 times 1 plus 3. Okay? So now notice, be careful here, because this x squared, you do that before you do the negative, because you don't have a parentheses around the negative x where you're squaring everything. The 1 gets squared first. So 1 squared is 1. Then you stick the negative on there, so it's going to be a negative 1 plus 2 plus 3. So 3 plus 2 is 5. 5 minus 1, or plus a negative 1, is 4. So 4 is your maximum, because remember, that is the y at the vertex. Okay, so our first answer here was that we've got a maximum, and the maximum is 4. And now, I'm going to just punch my stuff into the calculator here and graph it for you, and then we'll talk about domain and range. So again, I'm just going to go in here and I'm going to type in negative x squared plus 2x plus 3. And I'm going to do second function and table. And so, if I can read this here. So I've got a point at 1, 4. Let's see, where's my thing here? 1 and 1, 2, 3, 4. Okay, that's going to be the vertex because remember 1, x, 4, y. Okay, and then that's showing up on my calculator here as well. Then I'm going to have a point at 0, 1, 2, 3, which that shouldn't surprise you either because look at 3 is the y-intercept. And since this was the vertex, you know that there's going to be a point reflected over here. That's 2, 3. And then you have a point at 1, 2, 3, 0. And so you can imagine you're going to also have one here at negative 1, 0. And that is true. So this is going to look something like this. Okay, more or less. That's basically what it's going to look like. Now the point wasn't to graph this one, but the point is now on this to talk about the domain and the range. Okay, the one key thing to remember here is this. The domain for any of these quadratic functions, the domain, let's see, why am I having problems seeing my deal today? Okay, the domain will always be all reals. For any of these functions, these quadratic functions, the domain will always be all reals. And the range will always be dependent on what that maximum or minimum value is. Since we found that the maximum value was 4, that means that the range will be all the values of y that are less than or equal to 4. If it's a maximum and the maximum is 4, all your range or all your y's have to be less than 4. If it was a minimum and it was 4, then all your y's would have to be above 4. So you don't really need this graph to figure this out on this time on the domain and the ranges. But you know, I had this idea here, and then we'll be done. I'm going to change colors here. Go red, I guess. If you've got this graph here and you're trying to figure out domain and range, when you're trying to figure out the domain, remember it's the x's, right? Just if you took this whole graph and basically smushed all these points, either these ones up here straight down onto x, or these ones that are below x straight up onto x, if you smushed it all onto x, what would happen? You would get a line that would go straight across. Therefore, domain is all reals. Okay? Now if you, I'm going to change this one more time here. If you, green is good enough, I guess. If you took all of your, the parts of your graph here and smushed them all onto the y, okay, so all these ones over here is smushed onto the y this way, and these ones over here, what would happen? You'd get a line on y that would go here. Oh man, that's horrible. But you get the idea. It would go like this. So all of your range would be what? Starting at 4, and all of the numbers that are less than or equal to 4. So if you smushed or smashed, I don't know, what do you call that? Smashed it all onto the y-axis, it would start at 4 and go down. Or if you smashed them all onto the x-axis, it would cover everything. So I don't know if that helps or not, or that may be just really weird, but I thought about it while I was, I don't know, maybe it was a dream, who knows. But anyway, I thought, hey, that might be a good way to explain it. Let me know. Anyway, that's it. That's it for this this section. Those are the couple of types of problems that you'll be working on, and then we'll move on from there. So that's a little bit about quadratic functions. Thanks for joining me. We'll see you next time. Adios.